In this video, I will explain find the Fourier transform of the signal x of t shown in figure. Find the Fourier transform of the signal x of t shown in figure below. Using differentiation properties, differentiation property of the Fourier transform. Property of the Fourier transform. The waveform is like that. This is the waveform x of t. This is the time axis. This one is -2, -1. This one is 0, 1, 2, 1, and -1. Differentiation property means we have to find out dx of t by dt. Dx of t by dt, first differentiation. Next one, second differentiation. D square x of t by dt square, and then apply Fourier transform to this second differentiation. Now, here consider this area. Minus here, -2, -2 to 0. Here -2 to 0. Here coordinates -2 to 0. And here coordinates are from this point to this point, x -1, and y value is -1, -1, -1, -1, and -1. First of all, you have to find out the equation x1, y1, x2, y2. Consider this portion. y minus y1 into is equal to y2 minus y1 by x2 minus x1, x minus x1. Y minus y1 is 0. Y2 minus y1 minus 1 minus y1 is 0. x2 minus 1, x2 minus x1 is +2. X minus x1 is -2. That is minus into minus plus +2. Y is equal to -1 by 1 x plus 2. Here y is nothing but x of t minus of x is nothing but t plus 2. Therefore, x of t is equal to minus t minus 2. Consider these two coordinates, -2 to 0 and -1 to 1. Consider -2 to 0 and -1 and minus 1. And coming to this one, this portion, coming to this portion, this one, here the coordinates are minus 1, minus 1. Here the coordinates are 1, comma 1. You can find out x1, y1, x2, y2. Y minus y1, y minus or minus plus y plus 1, y2 minus y1, y2 is 1, y1 is 1, minus of minus plus 1, x2 minus x1, x2 is 1, minus of minus x1 is plus 1, x minus x1, x plus 1. Y plus 1 is equal to 2 by 2, 1, x plus 1. 1, 1 cancel. Y is nothing but x of t, x is nothing but t. We consider the intervals minus 1, and 1, comma 1. And coming to this one, the remaining portion is like that. This one, 1, 1 here, and here 2, comma 2, comma 1, 2, comma 0. Again consider these two, 1, comma 1 and 2, comma 0. 1, comma 1 and 2, comma 0. x1, y1, x2, y2. Up to this is for second one. This is 1, 1. This is for second. Divide the entire signal into 3 portions. Function into 3 portions. This is the third one. The third one, again y minus y1 is 1, y2 minus y1, 0 minus 1, x2 minus x1, 2 minus 1, x minus x1 is 1, y minus 1, minus 1 by 1, x minus 1, y minus 1 minus x plus 1. Y is x of t. This minus 1 is bring this side. X is t minus t plus 1 plus 1 minus t plus 2 x of t. This is the third equation. First one is for first portion. This is for the first portion. This is the portion 1. Minus 2, minus 1. The expression is x of t is equal to minus t minus 2. In the second one, this is the second one. This is the second one. Passing through this one, 1 minus 1. The equation is x of t is t. X of t is t in the second one. x of t equal to t. The third one, this is the third one. This is third one, 1, comma 2. This one is x of t. X of t, this is also x of t. The third one, x of t is equal to minus t plus 2. Coming to first differentiation, dx of t by dt here is equal to d by dt of minus t minus 2, minus t minus 2. d by dt of minus t minus 2, that is equal to minus dt by dt, that is equal to minus 1. Constant definition is 0. Coming to this one, dx of t by dt, differentiation with respect to t is a d by dt of t, that is equal to 1. Here dx of t by d, t is equal to d by dt of minus t plus 2 minus dt by dt, that is equal to minus 1. By using these differentiation properties, see the original waveform. This one is t. This one is x of t minus 2, minus 1, 0, 1, and 2. In the interval, first differentiation, dx of t by dt, and dx of t by dt. In the minus 2 minus 1 range, d of t by dt is here. This is the some slope is there. Slope, constant slope. The constant slope value is here, not this one. Negative. The slope is negative. Here the slope is negative. That is, this one is minus 2, minus 1, negative, that is minus 1. The constant slope is, that is minus 1, minus 1. In the interval minus 1 to plus 1 here, plus 1, this one is minus 1. In the second portion, the slope is 1. The slope is 1. That means minus 1 to 1. This one is a 1. Minus 1 to 1. The slope value is 1. This is the 1. This is 1. And 1 to 2. 1 to 2. The slope value is minus 1. 1 to 2. The slope value is minus 1. The slope value is minus 1 here. Minus 1. This is the dx of t by dt, first differentiation. And perform second differentiation. Second differentiation of this triangular waveform is converted into square waveform. And the second differentiation, this square waveform is converted into impulse functions. This is the time axis. This is the falling edge, rising edge. This is the constant one. This is the constant. This line is a constant. Rising edge, falling edge. This one is falling. Constant. This one is constant. This one is constant. This one is rising edge. Perform second differentiation. D square dx of t by dt square. This is the falling edge. The value is differentiation of this one is some impulse. The impulse value is here -1. The impulse value is here -1. Constant differentiation is 0. This is -2. This is -1. Here, 0 reached to 0, minimum value 0, 0 minus of -1, that is +1. This is the rising. Rising means the differentiation is also a rising value. +1. Here 0, here 0, here -1. 0 of -1, that is +1. Here one more value is also there, +1. +1 and +1 is +2. For -1 value is the impulse value is +2. Coming to this one, constant differentiation is 0. Constant differentiation is 0. Again, this is the falling. Here 0 is there. Here 1 is there. 0 minus 1, -1. This is also falling. The value is -1. -1, -1, -2. This is the for 1. Here the 1. The value is +2. Constant differentiation is 0. Here, this one, rising function. Rising function here reached to 0. Here is -1, 0 minus of -1, that is +1. This one is 2. This one is 2. The value is +1. This is the second differentiation. Therefore, convert this waveform into mathematical form. D square x of t by dt square. Here, delayed by -2. -2 means dou of t plus 2. Here minus sign is there. Amplitude is minus dou of t plus 2. Because left hand side, consider left hand side. Delay. Here +2 into here +2 into dou of t plus 1. +2 into dou of t plus 1. +2 into dou of t plus 1. Here -2, this one is -2. -2 into dou of t minus 1. Right hand side. T minus 1. Shifted that way, shifted right hand side. Plus amplitude is 1. Dou of t minus 2. T minus 2. This is a conversion, the conversion of that waveform into mathematical form. Apply Fourier transform. Fourier transform on both sides of that equation. Fourier transform. We know that dx of t by dt is the j omega x of omega. For this is second time differentiation. J omega whole power n. N is a second derivation, that is x of omega. By using a shifting property, time shifting property, Fourier transform of x of t minus t naught is equal to e power minus j omega t naught x of omega. Here, the same formula is applied here. Minus sign t naught is 2 plus 2 here minus here minus here minus. Here plus 2 means e power j omega to e power j 2 omega plus and x of omega after shifting a Fourier transform of dou of t. Fourier transform of dou of t Dirac delta function, that value is 1 into 1. Okay. Here plus 2 into e power j omega. T naught value is j omega and Fourier transform of dou of t, that is x of omega. 1 minus 2 into e power, here minus 1 is there, minus j omega, here minus j omega, here minus j omega, here plus minus 2 means e power minus 2j omega, e power minus 2j omega. Here e power j omega, e power minus j omega. Here e power j2 omega, e power minus j2 omega. Minus sign is common one. E j omega 2 minus e power minus j 2 omega. 2 is multiplied numerator and denominator, minus 2 into e power j omega minus e power minus j omega by 2j into 2j. Here 2j term is minus 2j term is bring outside. Here e power j2 omega minus e power minus j2 omega by 2j is sine 2 omega, sine 2 omega minus 2 into 2j. E power j omega minus e power minus j omega by 2j is sine omega. Here j square omega square x of omega, that is equal j square is minus 1 omega square x of omega minus, here minus into minus plus 2j here minus 2j omega plus 2 into e power j omega minus 2 e power minus j omega plus e power minus 2j omega. Here minus sign 2j and plus 1 here. 2 into e power j omega minus e power j omega by, here plus sign j square is minus 1 minus into minus plus 2j sine 2 omega minus into plus minus 4j sine omega. Therefore, x of omega is equal to 1 by omega square j into this one is 2 sine 2 omega minus 4 sine omega. This is the final Fourier transform expression of that waveform shown in above figure. With this, the derivation is completed. If you like this video, please subscribe the channel for further updates. Thank you.